So our fourth lesson, our second last one of the unit, is a 1.4 geometric series. Just like arithmetic series, the whole idea behind them is that we are going to be adding up the terms in a geometric sequence. So that's what this sentence here is telling us. Oops. So geometric series is finding the total number of branches on the fractal tree that you can draw, where we start with 1 and 2 branches, and each branch gets 2 more, and 2 more from here, etc. Okay, so it's the sum of the terms of the geometric sequence. It's a better way of thinking about it. For example, if we look at 6, 12, 24, 48, ... as an infinite geometric sequence, then 6, 12, 24, and 48, when they're being added, is the geometric series. So if we look at this, we can think of it as, okay, well, the sum of one term is just term 1. So it's just 6, the first term. But the sum of 2 terms is going to be term 1 and term 2. So that's 6 plus 12, which is 18. Sum of 3 terms is going to be 6 plus 12 plus 24, the first 3 terms, which is going to be 30, 42. In general, we have this equation here. Okay, very important. Okay, you will always be using this. Now, as we established in our previous lesson, R cannot be 0, or sorry, cannot be 1, and so it also can't be 0 in order for this to work. Okay, so T1 again is our first term, R is our common ratio, N is the number of terms that we're going up to, and Sn is how many terms are we including, starting at term 1. So in order to be able to do this, it says find the sum of the first 12 terms in the geometric series, 3, 12, 48, 192, etc. Okay, so we are going up to T12, or S12 is what we're actually trying to solve for, which means that N is 12. Term 1 is our first term, which is 3. And we need to figure out our R value, and we can do that by doing 12 divided by 3. Second term divided by previous term. And that ends up being 4. Now we can double check that 48 divided by 12 is also 4. So that works out lovely. So we actually have everything we need here. Now we just need to be able to fill in our equation. So I'm going to write it out before I actually start plugging things in. T1, 1 minus R to the power of N, divided by 1 minus R. Okay, so for S12, we've got 3 multiplied by 1 minus 4 to the power of 12, all divided by 1 minus 4. Okay, so we've got 3 multiplied by 1 minus, and according to our order of operations, don't forget that this part comes first. Okay, because exponents come before subtraction. Okay, so you're going to punch that into your calculator, and you're going to get a really big number. And then we can punch this all into our calculator. Again, we're going to subtract this from 1 before we multiply it by 3. And my final answer is going to be quite long as well. Okay, so 16,777,215. Okay, but it makes sense that we would have a really big number because these values, this is again going back to the different kinds of geometric sequences that we can have. This is definitely diverging. Okay, it's becoming wider and wider gaps between each consecutive term. So it's getting bigger and bigger. So I should expect a relatively large number for my sum.